Hello and welcome everyone to another Applied Flow Technology webinar. My name is Nick Vastine. I'm a business applications engineer here with AFT. And today I'm going to be walking you through our topic of the day, take notes, how to label, annotate, and better document your AFT model. Our agenda, as you'll see, is going to be pretty comprehensive. So there's a lot of line items, but luckily most of these line items are pretty small. We'll keep coming back to this agenda so we can see how we're progressing through. And then if you have any questions, feel free to leave a comment, ask a question, or shoot us an email at the email address at the end of the presentation. So the structure of the webinar, we're going to go kind of piece by piece through different segments or sections of our software and introduce ways that you can better document or take notes on your model or analysis. Now, fair warning, if the agenda didn't scare you enough, there are quite a few different topics, and we're covering it ideally within the hour webinar that we have allotted. So at some points, you might feel a bit confused or overwhelmed, but luckily, again, modeling isn't a closed book exam. There's no test at the end. You can always come back to this webinar or look through our documentation or do some examples and follow along to really refine these skills. My main intention with this presentation is exposing users to a lot of resources and a lot of topics that they may not be considering as you're going through your standard model building, analysis, and reporting process. So hopefully everyone here will learn something new, especially when I prepare these webinars, I learn something new as well. So I'm excited to share those findings with you. Before we jump into the actual content, just for a bit of context, we should address the question, why should you leave better notes at all? What's wrong with just creating a model, not documenting everything? If there's no documentation, then it can never be out of date. By implementing a lot of these features and resources, you're going to get quite a few benefits, not only to the model building process and for your own analysis, but any time that you're going to come back to your particular system and your particular model. I would say the most valuable thing that we'll gain from this presentation and from implementing these features is we want to make our model more intuitive to interpret and then a lot easier to report on. So we might have a system that has thousands of pipes, dozens of pumps, but we might be hyper-focused on only some aspects of that model. Or as we get into those really big complex systems, how can we color code or how can we isolate components, again, making it easier on us to interpret and therefore easier for us to explain later. By having that better understanding of our system, we can also make modifications faster. In particular, we'll look at features like scenarios and how we can leverage scenarios to test a wide range of different cases in a single model file. Within those scenarios, taking better notes is going to help us also track decisions or changes and alternatives as we're going through this evaluation process. So if we need to make a change, we can take a note. We don't have to track all of that externally. It can all be associated with the model file itself. Along those same lines, as we're developing a model, because you're pulling from all these different resources, from drawings or from walkdowns or from different data sheets, again, it can be very challenging to know what piece of information came from where. So by incorporating that all into the model, your model becomes this sort of one source of truth. You don't have to dig around through different files, cross-check information. You can also record your sources and other design justifications within that system. One quote I like to come back to, according to the internet, it was an ancient Chinese proverb or something said by Abraham Lincoln or somewhere in between, but they say that the faintest ink is more powerful than the strongest memory. So especially as you're building out your system, that's usually going to be when you're most familiar with building the model, with all of these design alternatives, what you were doing in the analysis. So by taking good notes, you're investing for the future. So when you come back and have to make a minor change or an update to a report or a different type of analysis, you have this strong starting point to kick off from. But if you're all here, you probably have a good idea of why you should leave better notes. So we'll start getting into the content itself. First one that we'll take a look at is workspace objects. So these are things like pipes and junctions that we'll have on the workspace within our software. So some questions we might want to answer in this section is, where did this data come from? Where might we want to document that? And how can I make it easier to find key components within my system? So the first thing we'll take a look at is, again, pretty intuitive. How do we name our objects to make it easy to search them? And then also easy when we're doing reporting if we need to export data or identify kind of key points of information. So we'll go into the software. And naming comes in when we are doing our object definition. So here in the properties window, up here in the name, you can make this name more clear instead of just pump. If you have something like a equipment tag, maybe you'll name this pump P101. Or if you have things like heat exchangers, instead of just heat exchanger, maybe you call that heat exchanger 101. So associating your model with the larger engineering design process, if it's universally named this equipment tag and other documentation, it makes sense to name it the same way in your system. Often in heat exchanger systems, especially like cooling water systems, these might be different discrete consumers that we're supplying flow to. So maybe instead of the heat exchanger, maybe this is our distillation column and we're feeding it to our reboiler or cooling our reflux stream, something like that. Or if we had a city distribution system, maybe this is City Hall. So again, going beyond just what does this heat exchanger cause in terms of pressure loss and flow, what does it really represent in the physical system? So naming, pretty intuitive, not something we're going to belabor. And if you're using a previous version of the software, it might prompt you to add that name of the object to the workspace. We'll show a little bit later in the presentation how to show, we'll call them key component names using workspace layers. So again, changing the name, it's valuable to label your key components. So if you're going to keep coming back to a pump to change out the pump curve, for example, or see how much flow is going to a heat exchanger, making that small investment of naming it properly makes it a lot easier when we go to search for it later in the presentation or later in the process. We can also include more complex notes into our junctions. So the name, you want to be nice, short, and concise, but notes, we can be as comprehensive as we want. So we might want to list, where did this component come from? Who was the manufacturer? What's their provided part number? If we used field data to collect the loss information, when was that test done? Who did it? Maybe point to another report. And then other insights into the design. Again, anything you might want to make a note on. So here, if we go back into our junction, we have this notes tab, where this is just plain text, so we can copy and paste any type of information in here. So here, from my notepad, we have some notes describing that we developed a pump curve from field testing. Maybe here's our data points. And if we compared to our pump model, those data points should be consistent. And if they're not, that should be a flag. When did we buy the pump originally? If the concern is reliability, are we getting the amount of use that we expect out of it? And maybe our intended flow rate requirements. And again, notes, it's the value that you get out of it is the amount of effort that you put into it. And all of these notes along with names are searchable. So here, if we purchase this pump from FlowServe, if I go to the search bar and I search for FlowServe, or any component of FlowServe, it'll bring up that junction for us. In the same way, if we search for our equipment tag, maybe we search for 101, here we can see that it pulls it up based on name. So notes, again, useful for logging our input information. Where did this come from? What other relevant pieces of information do we have associated with that component? Sometimes you might want to actually change the number of your objects instead of just naming them a certain way. The most common way that I see this used is when you have different regions of your system. So let's say that we have maybe 3 plants or 3 different processes that we're supporting from a single cooling water system. We might have our cooling water supply, and then we might have heat exchangers 101 through 121, and that's a certain segment. and we'll have 201 through 221, that's a second segment, 301 through 321, that's a third segment. So we can use this numbering to say, hey, these are similar areas, so in our reporting, they're all grouped together. And we have a few ways to make it more convenient to renumber those objects in that way. So the first one I'll show you is what's called our renumber wizard. So let's say that we have a area of our model like this. Or before we do the renumber wizard, let's show how you can just change the number of one junction. So if we double click here, maybe instead of pump 4, we'll name this junction. So this is our object number 101. And if we click OK, here we can see now pump 101, junction 101. Now that'll run into issues if we have heat exchanger 101 because we can't also name this 101. This has to be unique to each object. Now, if we wanted to make different segments, let's say that we have this area and we have pipe 11, 12, 13, 14, 15, 16, et cetera, and we want to have pipe 111 through 119, or junctions 111 through 116. What we can do, if we wanted to modify the objects directly, we can select them and then go to Edit, Renumber. And here we have a few different options. We can use the renumbering wizard. That's useful for sequential numbering. So if I wanted to name this junction 14, it'll resolve the difference, make this 14, and renumber this one automatically. And it can also renumber things like pipes that are following those junctions. Automatic renumbering, that'll also renumber them sequentially. So I might say start from pipe 11 here, and along this flow path, increment them one by one. Here we're going to use this increment. And here we're just going to continue renumbering. And here I'll say increment the numbers by 100. And now I can see it's renumbered all of those junctions by 100. And maybe I use that as my, again, region of heat exchangers in this case. If I wanted to copy a common design, maybe the piping and heat exchangers are all the same, but we have a 100, 200, and 300. I can select all of my objects, and I can also use this tool called Duplicate Special. Duplicate Special is just a more complex copy and paste, where here, when I paste it, I want to increment those selected pipe numbers by 100 again. So now, when I paste them in, I can see now I'm at 200, 212, 213, instead of continuing typically from just the highest number that we have in the model. And again, that's done from Duplicate Special, found here in the Edit window. And the main appeal, again, of investing in that numbering is so that way when I go to model data or to output, it's going to automatically group all of those objects together. So that is numbering. Again, remember the intent of the webinar is a bit of exposure to the different features, and it can be a lot to interpret. The final thing we'll talk about with Workspace objects is customizing the icon itself and how does it look within your model. And new to our latest versions, we can also add our own custom icons. So especially in cases like general components, where these components represent things that don't have their own correlations and equations, this could be something like a filter or a dirty screen or a complex heat exchanger where we don't have the same correlations. It can be useful to represent this general component instead of having it solely as this little icon. If we right-click on the component here on the left in the toolbox, we can actually customize what does that component look like. So am I representing a heat exchanger? Am I representing a screen or an orifice? Some sort of area change, or just a black box. And if I right-click this and I change, let's say, to this icon and click OK. It'll also update on the workspace. So it'll update the default of whatever junctions are using on the workspace already, and any new junctions I add will also have that same icon. Especially for general components, but this applies for any of our junctions. You can do the same customization. We can also now add new icons. So if we click Add Image, here I have this picture of a corn dog. And now, if I was representing a corn dog in my system, we can see that it's represented here. We can connect pipes to it. And again, it behaves the exact same way as our normal junction iconography. Note it might be a bit more complex to share with these icons, so keep that in mind before you invest, a lot of effort customizing every icon, because if it's only clear because of the icon you have, that might not be a well-documented or well-annotated model. So here we'll set this back to our default, and we'll go ahead and say goodbye to the corn dog icon. If you wanted to change individual junctions, so instead of changing the default, you can also go into each junction, go to the optional tab, and then change the icon from here. So that might be useful for distinguishing different types of pumps, for example. We'll also talk a little bit later about how we can customize other aspects like the size and the color of these junctions when we get into Workspace layers. So there we go. There's what we'll call chapter 1. How do we modify the objects themselves to make it more clear? What are they representing? What kind of information do we have? The next chapter, we'll take a look at features more specific to the workspace itself. So broadening beyond the object into the workspace, and then we'll look at, again, those other sections. So some questions we might want to answer is, what is my model representing? So again, how can I visually show a cooling water system, for example? How do I find key points of interest? So if I'm going to constantly come back to the same pumps, how do I locate them very quickly? And then what display options do I have outside of objects? So we saw how we can change object iconography. We'll also change object size and color a little bit later, but for more general information, what does that look like for annotations, for example? So this will be chapter 2. The first thing we'll take a look at is how can we bring in a background. Again, backgrounds are a very clear way to show this is what this model is representing. There's usually 3 different kinds of background imagery that I've seen, at least in my experience. And if we go to File and Background Picture, we can load our background picture. So one common way might be looking at a map. So imagine you're a utilities company, or you're doing a district cooling system where you have these really spread out consumers. Maybe you have City Hall, maybe you have the Target Center, and you can show, again, visually, here's who those consumers are, here's my source of cooling water, for example, and here's how they're all connected. For much more smaller scale systems, maybe more on the process side, here if we go to background picture under File and unload the background picture, it's also common to see more satellite imagery style pictures, where you might have tanks represented as tanks within your system, and you can demonstrate the connected piping, or if you have a centralized pumping station and you have different cases flowing to different tanks. Again, from just looking at the model placed on top of the picture, it should be very evident what are we representing with this system. The last one, which is, in my opinion, a bit less common, is drawing on top of isometrics or on top of PNIDs, just because it might be too much information. Though, again, any image that you have, you can bring into the workspace, draw your model on top of it, and it makes it very clear from the get-go, what does this model represent? So backgrounds, put very simply. The next feature we'll talk about is the search feature, and this is where we get to kind of reap all of the benefits from investing in good numbering and good naming and leaving good notes. So most often you're going to be searching from this top search bar. At least that's what I do in my experience, where we can search for things like junction numbers. So if I just search for junction 101, that'll appear here. And it'll also search for the name of the junction as well. If you include any notes, for example, the flowserve note that we had included, it'll also search for that as well. So if we type flowserve, again, or if we search any of the other terms included in those notes, they'll appear here. And when we click on it, it'll bring us directly to that component. So again, if I search flowserve, boom, selected, ready to go. So search can be useful, but imagine a case where we've named both of our pumps something else and we try to search for pumps. It might be more challenging to identify the different pumps in our system. So instead of using the search bar, if we do Control F to find, here we can see searching either by number or all of our different pipes, all of our different junctions. And you can also restrict this search box a bit further. So if I'm only looking for pumps, even if I didn't have pump in the name, it would appear in this list because it's based on the object type. If we were building our model and we needed to define all of our pipes and junctions, we can also use find and show undefined, or use our status light here in the lower right. You can also use special conditions, and typically, if we're going to be coming back to junctions over and over, it would be useful to specify what we call a bookmark. So bookmarks are actually a feature that I learned a lot more about in doing this presentation and preparing for this. And we can bookmark specific objects to make it easier to find. So again, here we have a relatively simple system, but extrapolate, imagine a 1,000 and 1,000 pipe system. And maybe I'm testing different pump curves, and I'm always going to be coming back to this same pump. So regardless where I am in my system, I want to be able to quickly jump to this particular piece of equipment. What we can do is create a bookmark. We do that from the View menu and then Bookmarks. Here we even have a keyboard shortcut under Control B. And when we set this bookmark, it doesn't look like anything really happened. But what it allows us to do, either in that Find window, where now it's listed here under the bookmarks at the bottom, or we have another keyboard shortcut that'll bring us directly to that bookmarked object. So if we go View and then Bookmarks, we have Next Bookmark and Previous Bookmark with F9 and Shift F9. Now imagine I'm all the way over here in my system, and if I hit F9, it'll jump directly to this pump. We'll see how this will be useful for Workspace layers as well. And so with that, we can combine Workspace layers and bookmarks to quickly jump between junctions and see exactly what information we're reporting on. So if we're checking efficiency or head rise or speed, we can jump directly to the relevant junction. The next thing we'll touch on is Select Special. Select Special will also touch on some other cool selection tools. But this allows us to select objects based on things like how have we named the object, how is it numbered, and other properties. One other thing I'll show is you can also select previous selections if you accidentally misclick. So let's start first with the misclick option. So let's say I wanted to make a profile graph and it was going all the way through here, and I accidentally misclick and I lose all of my selection progress. Instead of starting from scratch and highlighting those same pipes, if I go to Edit and then select the last selection, well, now it's recovered all of my work. I can continue my selection, and I don't have that frustration, especially if you're doing a very intense profile selection. Before we go to Select Special, one other selection tool I'll show you is selecting a specific flow path. So let's say that I wanted to show how is my pressure changing from this pressure inlet into my spray system, and as my flow is reduced through all of these different sprays, What does my pressure profile look along that flow path? So if I select the first object and the second object, I can go to Edit, select the shortest path, and I'll go from A to B, and then it's automatically selected for me. So especially useful when making those profile graphs or profile animations in the case of transient analysis. Select Special, if we go to Select Special here from the Edit window, or using keyboard shortcut F6, this provides us a way to, again, pick and choose different objects from the workspace. If they were already selected from the workspace, they would usually be highlighted here. So to demonstrate, if we have these objects selected and go to Select Special, it automatically carries over that selection. You might run into cases where you need to only select a few pipes or maybe all of your control valves. And here, if we change this selection type, that gives us much more flexibility to pick and choose what things are we selecting. So if I wanted to show based on pipe input properties, maybe I'm resizing a pipe from, let's say, 10 centimeters. So maybe everything from 9 to 11 centimeters. If I click Select Pipes, this isn't the best example because we don't have any pipes between this. But if I go in a wider range, maybe 0 to 100, you can see all of my pipes fall into that selection. Another common one might be adding groups, which we'll touch on here in a moment, and then other pipe output properties. So maybe we are trying to identify too high of a velocity in our system. If we do pipe output properties and velocity, we can flag everything that falls within an unacceptable range or outside of our acceptable range. So that's Select Special. You'll also see that special selection in a few other places in our software. I'll point it out when we make a graph here in the next section as well. So say that we go through all of this work to create a selection. How can we save that selection to use it again in the future? If I'm doing massive pipe changes, maybe I have 100 pipes and I'm testing them at 5 inches, 6 inches, 8 inches. I don't want to constantly be reselecting and re-identifying those pipes, right? So groups let us save those selections so that we can use them again in the future. So let's say again that we want to make a plot of our flow path through this lower path. I might go to Edit, select my shortest path as we did before, but I don't want to do those steps every time. If I go to Edit, and then Groups, here we can create a selection group. And in this case, we'll name it Lower Path. Oops. Apparently it already exists, so we'll clear it out real quick. And then we'll create our group again from Edit, Groups, Create. And we'll name this Lower Path. And here you can see, very similar to Select Special, we can pick and choose the different pipes and junctions. Or even within this group, we can again use that special selection to pick out things like pipe diameters or based on name or junction number, things like that. And now if I go make other changes to my model, yada, 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 if I go to Edit and then Groups, I can now hit Select my lower path group that I created, and then it's selecting it again for me. So instead of constantly recreating those selections as you're making graphs or other output, you can make the group once and then leverage it for all of that other analysis. One feature specific to groups, which I think is really valuable, we'll make one other group, this time doing the upper flow path. So again, from Edit, select shortest path when we select 2 junctions, and then we'll create a new group called our upper path. Sweet. So when we run our model, oops, let's disable that real quick. So we'll run our model, And now if we go to our graph results, now when we make our profile graph, I don't have to remember what pipes I have selected. I don't need to select them on the workspace and use workspace selection. I can use this special, again, this very common select special tool. Hopefully now it's more apparent that you can use this in all sorts of cases. And here I can pick my groups if I want my lower path, or if I wanted my upper path. I can use this again for that repeated selection. You might run into cases where you have branching systems and you want to compare how does the pressure change along those two different paths. So by default, the profiles are limited to a single path, but if you invest in using groups, you can also plot those multiple paths using those same group selections. So here, I believe this was our upper path, if I remember correctly. And now on the same plot, I can see the pressure coming in. These are all the shared pipes across both of those flow paths. And then where they start to deviate, now I can see at a glance, how is the pressure going to vary? And you have all the same flexibility as our graph manager usually provides to add other variables like velocity, or if we wanted to look at how does our mass flow change, again, as we're discharging more fluid through those sprays on the way to the end of the flow path. Again, that's accessed from here, the profile graph, and then we want to plot multiple paths using groups. We'll come back to this for some of the graph results, annotations, and notes. But again, that's probably the most common application for groups, besides maybe grouping all of my heat exchangers or all the pipes of a certain size, things of that nature. The last thing we'll show on the workspace is how do we add annotations, and we'll show this in a little bit more detail because it has been kind of new and improved for our latest versions, where most often we have, again, notes within objects or notes in other places in our model, but we want to make it as visible as possible for someone opening the model fresh. What are we trying to represent with this system? So for this one, we'll jump back to our other example. And here in our toolbox where we add our junctions and our pipes, we'll click our annotation tool. And now in the latest version, you can see we have this range of different shapes which we include. So let's add a rectangle. And maybe I want to show this as a pump station. Now this isn't the most valuable one because it's covering up all of our information. So here we can change the shape color, and instead of it being white, maybe we make it transparent. And now I can see what is being contained within this annotation box. If I wanted to make my border thicker, I can control that here. And maybe I make it a dashed line to really emphasize my pump station. And not only can you draw with it and color it and have that range of different shapes that we've shown, you can also include text in these annotations. So maybe this is our pump station. When we click OK, here it's showing in the top left by default, but as you can see, there's a lot of customization options here in the annotations. If I have this exactly how I want it, I can also save that as a new default annotation. And now I believe if we draw another rectangle, here we can see that it inherits all of those same properties. So if you're labeling different areas of your model, maybe invest a lot of time in getting it exactly how you want it as a template, set it as your default, and then you can continue to use that same format for all of your other annotations. The annotations, you can also add things like lines. So if you're pointing to a specific thing, obviously more complex font. And as we'll see later in the presentation, you can also control the visibility of these annotations using Workspace layers. So that's really everything we'll show for annotations for now. Again, as you go through, it's going to be impossible for me to explain it concisely, but if you draw out an annotation and experiment with these different options, you'll be able to find, again, a lot more flexibility than we've had in the past creating those annotations. And again, some common applications might be denoting different areas. If you're leaving a note, maybe you're saying all of these control valves are set to the same flow rate. Any revisions you might have to make. So if you're doing more thorough model review, you might tag a certain area of the model as revision 4, saying, hey, we've updated these pump curves, for example. But again, just more flexibility. How can I label, annotate, and document within the workspace of the model? So that is chapter 2. Now we'll take a look at chapter 3, which is really how do we look at our tabulated information, and then how do we interpret our output results? So where do we find all the input notes that we spent so much time meticulously entering? And then also, how can we call out specific results to make it more intuitive as we come back to analysis or tie it into our kind of finalized report? So we'll start with model data, and we'll highlight that we have all of our notes anywhere in our objects, in our pipes, and in our junctions. They all get consolidated in model data. So if we move on over to model data here, and we go to this notes tab at the top, here we can see any scenario notes, which we'll touch on here in a little bit later, any notes in our pipes, and then any notes within our junctions. So as you can imagine, as you list them all in the different objects, they all get consolidated here, which you can then copy and paste if you need it externally, or if you want to include this in a printout of all of your model data. So maybe you're adding all of the specifications for your system. If you click here on the print data, or the print settings, we'll say, we want to add in our notes. And if we click OK when we go to print it, here we have all of that general information, and here we have all of the notes that we would have added into our different objects. So again, useful to consolidate all of that work that we've done, clarifying any of the information going into the input of the model. Very streamlined, not a lot in model data. Next, we'll take a look at output, where we'll look at some different features, including design alerts, notes, and sorting. So let's say that we run our model and we take a look at our output. And one of our jobs in this analysis is we want to identify any pipes that are above, let's say, 5 meters per second in velocity. That's a bad example. Let's do anything above 4 meters per second in velocity. So we could go item by item and say, okay, these are of concern, or we can create what's called a design alert. And a design alert is going to flag the user anytime a parameter goes outside of the acceptable criteria. So for our velocity, we want to flag it anytime it's greater than 4 meters per second. The easiest way to do this is by selecting the parameter itself. Here in output, if we right click and we click create design alert, we're brought to this simplified design alert manager where we can say our max velocity, and we want to be alerted. So we want the software to tell us when the value of our velocity is greater than 4 meters per second. You can limit that to different pipes. Hey, we see that select special again. Or if we have a universal design requirement, we can select them to all of our pipes. So when we click OK, now when we rerun our model, or anytime we make changes to our system and generate output, we receive these pipe design alert notices, and then we'll also see them flagged directly in our output. Design alerts can be used in a lot more ways than just flagging velocity or perhaps pressure. If you go to the Tools menu and Design Alerts, this is our full Design Alert Manager, where you can add new design alerts that apply to pipes or junction specific. Maybe if you're looking at a pump, you want to flag it anytime that you go outside of the acceptable % of best efficiency point, or if we're losing NPSH margin and we're getting close to cavitating our pump, we want to be flagged as a user. And again, a lot of the parameters that we can report on, you can add a design alert for to automatically flag you as the user if this design invalidates our design requirements. And again, it makes it a lot more useful to send someone a model with these design alerts built in, pointing out the specific areas that are problematic instead of writing it in a report and then including a screenshot. If we wanted to include a note on these pipes, or maybe we have a pump, and let's say that we have a measured volumetric flow rate and our modeled volumetric flow rate is different. If we right-click on a cell, instead of creating a design alert, we can add a note. And let's say that our field measurement was 100 cubic meters per hour. Now, if I hover over it, I can see that note. It makes it much more clear. And again, it's flagged to the user to say, hey, there's some more context for where this number came from. The last thing we'll show with output, let's say that you wanted to resolve issues in your system and velocity issues in particular. It might be valuable to identify where are the most problematic areas in my model. And to do that, we might want to say the higher velocity through that piping, the easier it is to justify replacing it, for example. To sort these, we can right-click the header here, and then we can sort it. Here we'll do descending, so that way our highest velocities are here on top. And now we can see at a glance what types of pipes in our system should we be replacing. So again, in review with output, we have our design alerts, which should flag us automatically anytime we go outside of our acceptable limits. Most often, what's a maximum velocity, maybe a maximum pressure or minimum pressure. We can add notes to specific output cells to provide more context. We can sort our output, so that way if we extract it to Excel or if we're trying to identify the most problematic areas, we don't need to bring it into Excel to filter it and to sort it further. The last one we'll talk about here is our graph results. And we'll show one, how do we save our graph list items? So if we make graphs in a particular format, when we make other changes to the system, it will automatically reload that graph. And then also, how can we annotate our graphs to make it more clear what's happening, or if we spent time on an analysis, it doesn't have to be a description in a report. We can point it out directly on the graph. For the graph results, we'll hop back to our other example. We'll clear this out real quick. So to save a graph, let's say we've spent a lot of time picking our pressure, velocity, and mass flow rate for our profiles. If I right-click the graph and add the graph to list, I'll call this our profile graph, or maybe profile comparison. And now if I make any other changes to my workspace, and for whatever reason my graph is lost, I can reload it from this graph list manager. And here it looks like we caused some issue, but we were able to load in. We'll look into this and see what happened there, but hopefully it won't prevent us from proceeding. The example I like to use here is a common engineering question where what's really driving flow in a system? Usually flow goes from high pressure to low pressure. Another way to think of it is high energy to low energy. But here in this piping profile, we see quite a few places where we have positive flow and it's going from low pressure to higher pressure. Now, if you just provided this graph to maybe a customer or to a manager, they might have the same question of what's going on with this pressure recovery. Now, if you remember this webinar and remember this topic, we can actually recover pressure, and we recover it by recovering kinetic energy. So remember, in this system, we put these side by side. We have all of this flow going through a main line, and we have these draws off our header going to these different sprays. And every time that we have a draw, every time we have this reduction in mass flow rate, depending on the size of the pipe, we might increase or we might decrease our velocity. More often, when we remove flow, we have less mass flowing through the same area, we see a reduction in velocity. And as we reduce that velocity, we are effectively converting some of that kinetic energy into potential energy in the form of pressure. So if we look here, we have this decrease in velocity on this red line. And at that same point, we see that increase in our pressure. And again, anytime we have this decrease in velocity, we have that similar increase in pressure. So it might be easy to explain that in a report, or if I wanted to really call it out here, I can add an annotation. Let's do it here on this one. We'll create our annotation and we'll call this pressure recovery from velocity decrease. Here, I don't believe we'll move it over, but in the same point, you can point out particular areas of your graph from velocity decrease from reduction in mass flow, for example. Then when you save this graph or extract it out to your report, or if you save this and regenerate your graph, let's do that as our example here. It'll actually save that annotation, again, making it more clear for the next person or for you coming back to your system, what's going on with these maybe unexpected results. So again, high level, how can we save those graph list items to make it easy to come back to, especially much later or more complex graphs we create? And then how can we add annotations to call out specific results? That is the end of, what would it be, chapter 3. Now we'll take a look at chapter 4, which is scenarios, which we'll also keep very high level. We have some other presentations that go into much more detail about scenarios, so we won't spend too much time here. And scenarios, again, are a way that we can organize all of our design cases or design alternatives. And some questions we might want to answer is, what are we varying in each case? If we think of each scenario as an experiment, what experiment or variable are we testing? How can we create scenarios in such a way that we can be efficient in what we're testing for sensitivity analysis, for example? And then also, how do we compare our results across the different cases that we have? So the most obvious thing of how do we make our models more easy to interpret is going to be, how do we name the scenarios within our scenario manager? So here, if we go back to our first example, here we have our base scenario, we have our initial pump curve, and then it looks like we have 3 different pumps that we're evaluating. So already from the names alone, it's pretty clear what this model is comparing. I might be maybe not the best example of good scenario naming. You can ask our development team when we're troubleshooting a model, or if we identify an issue and we're trying to identify the exact cause. What I wouldn't recommend is creating scenarios and just calling them test or test 1. Because again, someone else comes in and looks at your model, or you have to explain it to someone else. It's solely reliant on you to remember, what was I changing in each of these cases? So put some thought into how you're naming the scenarios, and that'll also come in handy. Also clear out this guy. That'll also come in handy when we are comparing our output results or when we're mass modifying our scenario manager. So while the name should be very short and concise, in the same way when we name our objects, we can also add notes to our different scenarios. And that's added down here in the lower right. So here, I might have pump A. I might say pump A is a replacement from flow serve, let's say. And if I select pump B, maybe pump B is from, I believe, let's say Grundfos. Pump C, let's say pump C is the same pump we already have, but new in Peller. And what you'll see, or at least what I found interesting about these scenario notes, is that you don't have to open the scenario to see them. So as you're scrolling through these, as I go from pump A here to pump B, I can see that those notes are updating automatically. So that makes it really easy to see at a glance. Imagine a much wider scenario tree to see what were we exactly testing from each of these scenarios, maybe what's the conclusion without going and looking at the results directly. And in those same ways, as we saw with the model data notes, if we go to model data, we can see those scenario notes log there as well. Scenario structure, we won't go into too much detail here because scenarios are kind of their own very complex feature. But if we think smartly, or if we anticipate some of the changes and analysis we'll have to do, we can structure our scenarios in a way that we can create a lot of scenarios very quickly. So let's say in this case, not only are we testing different pumps, maybe we're also going to test different pipe sizes for our different heat exchangers. So maybe our base case, we have this 4-inch piping, and I'll name this our 4-inch pipe. I can insert a scenario above it. This will be my new base scenario. And if I clone this 4-inch pipe scenario, and maybe we're comparing with buying 6-inch pipe instead, now I have pump A, B, and C operating with 4-inch piping, A, B, and C operating with 6-inch piping. And maybe sometimes we model with water, but sometimes we have to cycle a refrigerant for maybe more complex cases. Again, I'll call this my new base scenario. And if I clone this, now maybe we have our refrigerant. So you can see by naming things intuitively and being clear what each of these are testing, you can exponentially increase the number of scenarios that you have within your system. We won't go directly into scenario inheritance, but any change you make to a parent scenario will also trickle down to all of these child cases. So if I change my fluid from water to refrigerant here in this parent scenario, it'll transmit down to all of these other cases, and I only need to make the change in one spot. Let's say that we created all of these different cases. I don't want to go through and run them one by one, right? I don't want to sit, click run, wait until my model's done running, and then go to the next one and click run. I have better things to do. I have meetings to attend, I guess. So one thing that we include to mass run all of these different scenarios is what's called the batch run feature. And batch run is accessed from file and then start batch run. Where here, we're going to pick which of these cases do we want to run to generate output. And if I click add scenarios, here I can pick and choose or anything that doesn't have output. And when I click start run, it'll run through them all sequentially. I can go do other stuff. I can work on my report. I can answer emails. And now all of my output is prepared for me to review. So not necessarily a documentation feature, but again, something as you lean into scenarios and making them more clear of what is each one representing, how can you use the software to run all of those scenarios one after the other. Multi-scenario output and graphing, we'll touch on this very briefly, but if we go to our output control here in the upper left or under the tools menu, output control, here on the far right, I can select multi-scenario and I can select different cases. And here, this is also why it's important to name your scenarios well, because I can see it's all water, orange pipe, and then the different pumps I'm evaluating. And when I click OK, now I can see all of my results all tabulated together for ease of comparison. In the same way, we can apply design requirements or design alerts to flag us across the different scenarios. And if we needed to extract this information to Excel for whatever reason, we can copy this entire table. And if we bring Excel on over here, we can paste it in. We have all of our pipe 1 results, all of our pipe 2 results, et cetera, et cetera. We can do the same thing with multi-scenario graphing, though we won't do a full example here. But if you have multiple scenarios, you can click multi-scenario and then select different scenarios with output, and they'll be cross-plotted on the same graph. The last feature I'll show is scenario comparison, and this is how we can identify differences between scenarios. So let's say our naming was not very intuitive, or we get kind of lost in the excitement of building our model. And I want to make sure that I'm only changing exactly what I want to change in each of these cases, right? Especially for comparative analysis, if we have too many variables and we don't isolate our independent variable, how good are our results going to be? So if we go to the Tools menu, and we want to use the Scenario Comparison tool, here we can pick a few different cases. So here we're going to compare our sibling scenarios. And if we've done our job correctly, the only difference between these scenarios should be pump A, pump B, and pump C. But the comparison is going to check literally every input in your model. So if there is an unexpected change, if the fluid changed unexpectedly, this is how you would be able to flag that as the cause of discrepancy. So if we show our comparison, here we see exactly what we would expect. Our pump J4 and pump J5 have different pump curves because we're testing them in these different scenarios. So very useful, again, if you inherit a model and you're double checking someone's work and you're getting maybe unexpected results. Are these scenario comparisons, are what we change in each of these scenarios actually accurate to what's being said is being changed? And there is chapter 4. We'll wrap up on chapter 5. Workspace layers are a bit more intensive, especially if you're watching live. We're coming up to the hour, but I would say there's maybe 10 to 15 more minutes of content as we go through Workspace layers. And we do issue a recording, so if you have other meetings and other things to attend, you can always come back and review this final chapter of the presentation. Or if you're watching from the future and you're watching a recording, you already know how long it's going to take. So Workspace layers, this is a new feature for our latest versions in Fathom 13, Aero 10, Impulse 10, and Extreme 3. And this is a very powerful tool to control exactly what are we showing on the workspace and how can we make our input and output results much more intuitive. So similar to a lot of the other questions that we have in the other chapters, again, how can I highlight different points of interest? How can I simplify my model if I wanted to, again, highlight only the most relevant information? And then how can I visually represent different aspects of my system? So going beyond annotations, what can I do about the objects themselves to make it more intuitive to understand? So the first thing we'll show with Workspace layers is visibility. And visibility is the main controller of a lot of the other things that we'll talk about as these subsequent points. So back in our software, we'll work in this scenario here. And down here in the lower right, we have this Workspace Layers tab. You know it's important when we dedicate a whole tab to it and a whole kind of sub interface. As I mentioned, the first thing layers control is visibility, and we control it with this little eye icon here. So by default, we have this layer called the All Objects layer, and as it sounds, it includes all objects. So if I were to hide this layer by clicking the eye, all of my objects still exist, but they're not being shown at the moment. we'll see how this can be useful to isolate different parts of our model, for example. If you have a really complex system, again, you may not need all of the information for these elbows. I don't need to show these elbows in my system. So one case might be, how do we create a simplified view so that we only show what I'll call our key components? So things like our control valves and our heat exchangers. If I select all of our objects, let me move this out of the way for a moment. And if I deselect different components, let's say I get rid of all these branches and my elbows, and I want only what I have selected to appear on a layer. So I'll select it on the workspace. I'll create new layer from a workspace selection, and I'll call this a simplified view. Now, by adding this layer, it doesn't look like anything's changed. And the reason for that is these layers are additive. So if a branch junction appears on a visible layer, then it's going to override not seeing it on this simplified view. But if I turn off the all objects layer, because this branch junction doesn't appear on any of the visible layers, it then disappears. And now we can see at a glance, well, it's a much more simplified view. Maybe I want to simplify it further and I only want to show my pumps for whatever reason, really streamlining my model if I'm going to go check how these pumps are doing. I'll create a new layer from workspace selection. I'll call this my pumps layer. And if I turn off my simplified view, now only the pumps layer is showing. So the first key concept is layers control visibility. And that's useful because it can allow us to simplify the model or kind of isolate our analysis to a particular area instead of seeing the entire system comprehensively. The next thing we'll show is, along with controlling what we show for each of the objects, we also can show parameters for each of them. So if we have visual report users, this is how we can control, do we show our pipe lengths or our nominal sizes? And then as we get into output, what are our velocities or what are our pressures throughout our piping system? So if we go to the all objects layer, here when we open the layer, let's maybe show pumps instead as an example. Here we can see very clearly what objects are included on the layer, what's visible and what is not visible. It's important to note that we have to show the object itself in order to show its associated parameters. So if we go to junction parameters, here if I add the junction name, if we spent all that time adding our P101 equipment tags, we now show that parameter here on our pumps layer. And when I hide that pumps layer, it also hides the parameters that are associated with it. So again, if we show it, we show our parameters. To make this more dramatic, let's say that we also show things like our head rise or our volumetric flow rate through the pumps. So now, not only am I showing these pumps, I might instead be controlling, here's my pump output. And I don't need to see my pump output all the time, but if I have a particular report I'm generating, or I'm trying to figure out what's the flow discrepancy between these parallel pumps, I can include that as a layer. And when I'm done with it, I can hide it and simplify my system. So you can add all sorts of different parameters. If we take a look at the layer, you can create things like, if I'm checking my pipe input, maybe I want to show what are all of my pipe lengths, or what are all of my pipe nominal sizes. So let's go ahead and add this to the all objects layer and let's see how it looks. So I add our length. And if we add our nominal size, that's a bit strange. Let's try to add it to our simplified view instead. Again, we'll add the length. So now, instead of going back and forth between model data and our workspace or inspecting each one of these pipes, I can see at a glance, are any of them kind of too far off from what we would accept for our modeling accuracy. And in the same way, if we add in our nominal size, now we can see the 6 inches, 4-inch split, 6-inch recombined, and then our 4-inch flow to all of our heat exchangers. Now it's valuable to be, again, thoughtful in how you're creating these layers, because you can quickly fall into the trap of having too much information. But again, it's easy to hide the layer because the parameters are also associated with the layer itself. And so by hiding the layer, you also hide those parameters. The next thing we'll show is how we can control the style of our objects. So this is a bit different from changing the icon of each object, and instead we can change things like the size and the color. So let's create another layer. And here I want it to include all of my piping. If I wanted to create kind of another all objects layer, another way to do it is to do Control A to select everything. And then I will create a new layer from my workspace selection. And here, let's call this our cooling, heating, piping. Again, looks like nothing changed because we've just duplicated this all objects layer. So here in cooling, heating, piping, back on the style where we can control visibility of the objects on this layer, we can also control the size and the color. So in our case, maybe we want to show that those 6-inch pipes are larger than the 4-inch pipes. If I select them here on the workspace, I can click this workspace selection, and then I can make them thicker. So now visually, I can tell these pipes are a different diameter from these other pipes. In the case of our cooling water system, we can show here we have our cold water supply. We'll select all of those pipes, and I'll say everything I have selected here on the workspace. And I want to change the color. Let's do, for blue, let's just do sky blue. We can see that they all become updated. And if I release my selection, I can see that now my pipes are all color coded. And if I wanted to show my hot water return line, and I'll click none and pick them on the workspace. And now we'll pick a more red color. Let's do coral, sure. And now, visually, it should be much more intuitive to whoever's opening the model. Oh, we have our cold water supply and our hot water return line. Because these layers are additive, it's important to recognize that whatever layer is on top is going to cover up the layers below it. So if we add back our simplified view, here you can see we added back all those parameters, but it didn't bring the color from this simplified view. But if I reorder the layers, maybe I put simplified view on top, because this is all of our default settings, all of our gray pipe that's all the same thickness, it's overruling the style settings that we put for the cooling, heating, piping layer. And in the same way, if I hide this cooling, heating, piping layer, this becomes our new top layer, and that's ultimately what's displayed. So that's how we can control things like styling. So if I wanted to change not only the size and color of piping, if I had different types of pumps, maybe I color them differently, or maybe I make them big or small if they're a really big driving pump or a really small booster pump. But again, giving users more flexibility and creativity to show this is exactly what I'm representing with just these pipes and junctions in my model. Users of our software hopefully are also familiar with color maps, especially if you've used Visual Report in the past. And we can use Workspace layers to add those same color maps to our model. So here, instead of creating a standard layer, if we click New Layer and then Color Map, let's say we're looking at our pressure in our system. When I go to open the color map layer, we can see here's our static pressure maximum that we're checking, and we're going to color code the pipes based on this distribution. We can also see that distribution here. So when I close it, now at a glance, I have all of my, let's say, pipe input and all of my pressure maximums color coded. But see, it also overrides all of my style changes for my cold water supply and my hot water return. And like the other layers, if I hide this layer, it doesn't delete all of my input. It just goes to whatever is the next style. And it also combines all of the different parameters that we might list in these different layers. So you might create a color map for pressure. Maybe you make another color map for a velocity check. And now I can see that distribution, or I might, if we change this drop down to velocity, there we go. I can see how that distribution changes throughout my system. Or I might use this as a simplified check to say anything above 4 meters per second, I want to color that red. And that means that I would need to resize these two pipes if that's my velocity limit. And again, I can turn it off just like my other layers when I don't need it. And as soon as I do need it, bam, all my settings are saved. And I can grab a screenshot or, again, whatever other question I'm hoping to answer with my analysis. The last two are, again, pretty brief. The first is layer presets. So imagine as we build up more and more of these layers, because they kind of play off of one another, you might have a set of layers that you want to enable. So maybe I don't want my simplified view, and I don't want my all objects layer, and I only want to show this cooling, heating, and piping. With this selected, I can create a layer preset, and I'll say this is color coded. And regardless of what layers I'm showing, if I load that layer preset, it'll have exactly what I have specified. If I need to change it, I can add or remove layers. I can click Update. It'll overwrite my previous preset. If we show all again, now you can see that it saves only that pumps layer. And if I, again, change it and click Update, I hide all my layers. It'll load only those associated with the preset. We can then take these presets and link them to a scenario. So if we look at our active scenario in pump A, if I link it to pump A, now no matter what changes I make to my different layers, when I reload the scenario, it only brings over the two that I have included in this preset. So again, kind of compounding on top of scenarios. Maybe I have this one dedicated for a particular type of analysis, or I'm looking at different things for different scenarios. I can create those layer presets, link them to the scenario, and I don't have to worry when I pass my model on to someone else, are they going to look at it the same way that I've been looking at it? So those are those last two features for layer presets and then linking the scenarios. And again, we should have quite a few examples and other documentation as you start to familiarize yourself with layers. What I recommend is opening up an example model and just experimenting. The easiest way to learn is to look at, what have we provided? What could layers look like as pre-built? And then how can you replicate it in your own systems and in your own models? All right, and here we are coming up to the summary as our time together comes to a close. To be fair, I did give you a fair warning that this would be a lot of content. And again, we do provide recordings, or you're actively watching the recording if you want to come back and review some of these materials. So one of the biggest topics, again, beyond our software, making sure that you're investing time to create good notes, naming things thoughtfully, creating good documentation, so that way the next engineer using your model, or when you come back, who knows, 3 months, 6 months, 2 years later, you have a good understanding of what this model was and how it was representing your system. As I mentioned, models are going to outlive many projects. So by investing now, when you come back to a project for a minor change, it's going to be much faster. Or if you standardize it across your team, if you have to inherit a model from someone else, there's some base understanding of what's going on. We talked a lot about selection options. That was something I didn't really expect to include in the webinar, but I find them really valuable. And again, by automating that selection process, so you're sort of documenting your system in a different way by enabling you to create different types of graphs or to make selections and updates much faster as you're going through the analysis process. Then finally, as you can tell, there's a lot of little tips and tricks and little tools in the software that you may not be aware of. So the more you attend these webinars, the more you ask questions or kind of research through our documentation, the more that you will gain, and the better documented your model, when someone else inherits it, the more that your team members will benefit as well. So that takes us to the end of the webinar, a bit more than we bargained for in terms of the 1 hour of content, but if you've stuck around to the end, hopefully you've found new value and some new capabilities in the software you can incorporate into your own models. We're always looking for new webinar topics, so if you have any ideas, feel free to shoot them at webinars@aft.com. And if there are any questions after you review the webinar, you can send those to webinars@aft.com as well, and we'll send over a prompt response. Again, I want to thank everyone for attending, especially if you've made it all the way through to the end. And we'll see you in another AFT webinar, hopefully sometime soon. Thanks.